Yes, thank you. So I'm just gonna start right away with some more tooling. Um, I started building Soar with CMake and Conan. Conan is a package manager for C++ projects, and CMake is a build tool for the people that might have not been in touch with C++ very much. And I'm gonna touch on some topics, for example, why a new build system, what I needed it for, why CMake and Conan might be a little bit better than scones and what are the advantages or disadvantages, how the CMake build system works in general, and what is currently missing when you compare the CMake build system to the scones, like the old build system. So in case you want to switch to it or want to experiment with it, so you know what to expect and what you or not to expect. So why a new build system? First of all, I wanted a easier setup for Soar ROS. That's the ROS 2 integration of Soar, basically, that I wrote last year. I wanted to have dependency management and not have like in-repository management of the whole source tree. I wanted to have a reduced set of source, so I didn't want to have all the Swig bindings, all the Java stuff. I just wanted the pure C++ library just for performance and size and for easier integration. And I thought, how hard can it be to rebuild a C++ project? Yeah, might have done that a little bit other. I found that scones is very hard to understand. Just the documentation wise, it has a lot of global variables. And so I said, okay, let's use CMake for that. And I don't know if you use or you know it, ROS2 has a default tooling that's based on CMake. So an integration was very easy from that side. So what are the disadvantages and advantages of scones? It's Python based. It's a very well-known language, but it works with environment variables a lot, so it can be quite confusing how stuff works. It uses a lot of environment variables. That's what I already told. And exactly, the scope of the scripts is very confusing. I think you have a lot of like sub files and subdirectories that you have to know and have to know all the variables, and there's no real tooling around it. And it has like a lack of documentation usage examples, and that are pretty much the advantages of CMake, although CMake has its own language, but it's very descriptive, so it's very easy to pick up. It's just one hint. If you're starting to get into it, just search for modern CMake and have a look at their official documentation, because CMake is quite old as well, or has a long history. It's updated regularly, but old CMake doesn't necessarily work with new ones. It has a very wide adoption. It's almost can be considered as the de facto CPP build standard because it uses in the background a lot of new generators and stuff. Documentation, tutorials, and all stuff like that is up to date. It's the community is very big. It has packaging, it has testing, IDE integrations, and all kinds of stuff. And I didn't test that yet, but apparently CMake has faster build times. So that is interesting, especially if you test a lot in CI. So you have faster results and less CI usage. So how does the CMake build system work? That's very general for now with some Soar adoptions. So first of all, we call Conan. That's a package manager that brings in our dependencies. And then we just build and configure the project. Usually we run the C tests or the tests with the C test executable, and then we package it in CI. That is something you don't have to do on your own system. And yeah, wait a second. No, I'm back. So once, let's jump a level deeper. So once you call Conan the first time, there's a configuration file. That's the Conan file.py. That is something you can alter and, for example, add new dependencies if you're developing on Soar. So this generates 3 new configuration files, and basically you don't have to worry about them too much because they're all included in the build process and they just stay in the background. So the only 3 configuration files you have to adjust is the Conan file for dependencies. The CMake lists txt defines how the project is built, and the CMake presets file defines presets how to build the project. For example, a debug configuration, a release configuration, and tells which tests to run and so forth. So you don't have to enter all like the command line options and stuff. It's easier to use. I will show you in the next screen. So in the next step, if we want to run the tests, we can just reference the CMake presets and include our tests. The same with CPack. And so essentially it comes down to 3 files you can change to build Soar. And this is essentially true for all CMake projects with Conan. So it's a very standardized setup. So let's say you want to build Soar. What commands should you run? For example, you first have to install Conan. It's the same way for every system. So Windows, Mac, and Linux. You have to detect a profile. That's an important step. You have to install all the dependencies. So this Conan install build missing installs all the dependencies, and you need it for the debug and release. Otherwise, the includes don't work. That's a little bit of a drawback, but that's unfortunately how Conan works. So for example, you want to run or build Soar with individual commands. You can say, hey, I will configure me this project with the release test configuration, build it, test it, and then you can package it. And running these commands all the time is pretty annoying. So there's a workflow feature in C++ that does exactly this set of commands in just one line. So you can run it easily. And that is pretty much the same what is running in the CI pipeline. So you can mimic the CI pipeline on your device and figure out bugs if we have to fix any. So what's the benefit of this all? Essentially, this code snippet is all I need to include Soar in my CPP project. And afterwards, I can just link again the Soar library. It doesn't depend if it's a dynamic or static build. Obviously, there's some more missing above and below, but essentially that's the most important part, to link against Soar and use it. And this fetch content declare automatically pulls the latest development version from the GitHub branch and builds it on your local device with all the dependencies most of the time. And exactly, there's one disclaimer. The dependencies, for example, SQLite, are most likely installed on your system. If they are not, you have to install them manually right now, because we build with Conan in the GitHub repository, but we don't, or fetch content doesn't support fetching dependencies. So this is something you have to do on your own right now. But that can be fixed later on with this baseline of CMake projects. So what's missing if you compare sconce to CMake? This is just a screenshot from the current README of the Soar project. Here especially is the Soar visual, or the visual Soar was symbolic visual viewer from Soar is not built right now. It is called the Swig interfaces. The Python package is not built. And the Windows build is currently missing due to some bug fixes and stuff. So if you want to contribute, you're more than welcome to. And this is essentially the wrap up of my talk. If you have any questions, feel free. Otherwise, we can skip ahead to the next talk.
Okay. So we do have time for a question or two. If anybody that has a question, if you're online, just unmute and.
I don't know if John can see me, but
Okay.
So
Face the.
oh, the camera. Yeah. I feel like I'm looking at Big Brother. Where is it?
Don't worry about it. Just.
Yeah. So are you gonna provide, I guess, basically like the default CMake config files if we want to immediately switch our own personal Soar build from sconce to CMake? Is there something that we can do that's pretty quick to set up? Or we'll have to figure all the config files out ourselves?
Actually, there's a build script, so it's called build.sh. You can just run with your configuration, and it just runs a default debug build. And I set up the options in the CMake file I hope as a very conscious default. So you're building a limited set, but you can also say, hey, okay, I want to include, for example, other packages of Soar. For example, I want to build the Soar CLI interface. or I want to build the unit test, I want to build the performance test, you can enable these options. And I think it's fairly thoroughly commented in the CMake lists file.
Thank you.
I had a question for you. Is there still time?
Yeah. Cool.
In working with CMake, I guess you kind of mentioned this in the talk, but I was kind of hoping for a little bit more detail. How difficult was it to adapt to, I guess, creating your own version of Soar? That is a fascinating project to me in particular.
I mean, it was like over the course of a year or something where I jumped back and forth to it. So it was like here and there an hour or something.
Mm-hmm.
But canceling out or deducting the time it took me to learn CMake, I think it's not that hard actually, especially with current AI tools where you can use to explain it. For example, if you copy the CMake file and try to learn it, it's pretty good, I think. And building Soar with the sconce files was like the major part to understand what sconce does and what like flags it sets to mimic the build structure and the build options, basically. After that, it went pretty good, actually. I was surprised how fast it got, or how fast I got it to work.
Okay, thank you.
No worries, you're welcome.
Well, thanks a lot, not only for your talk, but for all your service. It's great to have somebody contributing so much to the project. So thank you.